Some math tips by Mrs. Kirby. So here are some key points to avoid very common mistakes. I have 3 slides of key points, okay? I promise you I am giving you everything you need to pass this test the first time. But your success is up to you. You must understand and apply the information that I'm giving you, okay? All right. So first, follow the instructions in the stem of the question. Do not round up unless it says round up. If it does not say do it, do not do it. Do not assume anything. Whatever the question is asking you, that's what you want to address. Okay? Do not read into these questions. Ask yourself, what are they asking me for? What are they asking me? So, figure out what the question wants at the end. Then figure out what do you need to do in order to obtain the answer. Okay? So, what are they asking me or what do they need to know? What do I need to do, if anything, to solve the problem? Because some of the problems, some of the questions will give you just a scenario, and it's just a matter of they want to see if you understand when they state that 1 ml is equal to 1 milligram, that you can actually say, yes, I understand 1 ml is equal to 1 milligram. So there may be no math to do. It may just be testing your comprehension of the actual question. Okay? But if there's something that needs to be solved for, and I'm going to tell you for your exam, most of them they do need to be solved for, okay? Then figure out what are they asking you and then get that particular answer. Sometimes you may need to convert from one unit of measure to another unit of measure. Sometimes you don't need any conversion at all. And you can just utilize the formula and obtain your answer. Okay? So if you recall, when we first started our math, it was just plug the numbers into our formula and then get our answer. Then it got a little bit harder where we plugged the numbers into our formula after we converted, right? So we might have had micrograms and milligrams and we did our conversion. Then we plugged the numbers after we converted it to equal units, plugged the equal units into the formula, desired over half times supply, and got our correct answer. So you have to figure out, do I need to convert it? And here's your answer. If the units are equivalent, you do not need to convert it. If the units are not equivalent, you do need to convert it. Okay? Which is why I told you that chart, you must know those equivalents. Okay? Because that's going to help you with your conversions. All right. And is there any additional steps? We had a question where you had to determine how much you used for the day. So it was 3 milligrams of morphine. It was given 3 times a day, and it was how many units, how many milligrams were used for the day, which was 9 milligrams. And 9 milligrams was actually equal to 9 mLs because the ratio in the morphine bottle was 1 milligram equals 1 ml. Hopefully you guys all remember this problem. Then they wanted to know how much was left in the bottle. Okay, so they gave you 30 milliliters of morphine, a bottle of 30 milliliters of morphine. You used 9 milliliters of morphine, and all you had to do is subtract the amount that you used for the day from the bottle, and it would give you 21 milliliters of morphine left. Very simple equation. Seemed a little tricky for some of you guys, but it really was straightforward, very simple. So after you solved for how much you actually needed to get for 1 dose, then multiply that by 3 doses, then you had to take that answer and subtract it from the amount that was actually in the bottle originally. And that was your answer. So you have to think about what do you actually need to do to solve the problem. Sometimes you have to do something before you use the formula, right? Like converting units to make it equivalent. Or sometimes you need to do something after you utilize the formula, such as deciding how much was actually, if you know one dose is equal to 3 milligrams, then we need to know if I gave 3 doses, how many doses did I use, right? So you're multiplying it by 3. Then you subtract it from the volume of the bottle, which is 30 milliliters. Now we have our answer. So pay attention to all keywords in the stem of your question. Very important. We're going to go over some more key points. And first, I want to say I don't want to scare you. The test I feel is very easy, and I feel that each of you are well prepared for this test. I don't expect anyone to get a horrible score in this exam. So please, if you hear the emphasis in my voice, it's just because I want you guys to pass the first time. And I feel like you should be prepared to pass the first time. And some of you, I believe, you just have to believe in yourself. But I know you know what you need to know to pass this test. Okay? So, key points to remember. Okay, common mistakes. So, here's an example. So, rounding to the nearest whole number means that 10.2 should be rounded to 10. So a whole number is a number without any numbers behind the decimal point, okay? And I'm just making it simple and plain, and I don't want to assume anyone knows anything because sometimes people just don't ask questions, okay? So 10.2 is not a whole number, but 10 is a whole number, okay? So if you are writing a whole number, you do not need to put any trailing zeros. I'm on the second bullet point. So when I say trailing zeros, that is any zeros after the decimal point. So when you see the number 10 written, 10, there is an imaginary decimal point behind it, which makes 10 the whole number. Okay, we all know that. Now, the trailing zeros come where you put 10.0. That is a no-no for med math. Why is it a no-no? It's a no-no because it's room for error. Someone can interpret that as 100, and we know that 10 and 100 are very different. You give someone 100 milligrams and they're supposed to have 10 milligrams, you can kill them. Okay? So we don't put any trailing zeros, we don't put any decimal points, we just put the whole number. Okay? This is for whole numbers. I am talking about bullet point 1 and 2 right now. And so bullet point 3 is showing you the example of what is incorrect. Okay? An example of trailing zeros is rounding 10.2 to 10.0. That is incorrect. There should not be a decimal and a zero. 10 is a whole number, then 10 it is. We don't need the point zero to know it's a whole number. Okay? Please don't leave points on the table by putting these trailing zeros. All right. Now, the other common mistake by students where they lose unnecessary points is putting a leading zero before the decimal if a number is less than 1. Okay? If you have a true decimal number, you have to have a leading zero. I'm sorry, did I say that correctly? So you have to have a leading zero before the decimal number. Okay, so our example, I am on bullet point 5. An example of a leading zero is 0.5. That is written correctly. Okay, that eliminates error. That allows the person coming behind you to know 0 is before the 5. So that's definitely a decimal point there. There's no mistaking it. Okay? This is less than 1. It is 0.5. Okay, so an incorrect example of not having leading zeros is 0.5. So instead of putting 0.5, the nurse puts 0.5. Well, it's a possibility the person coming behind her might look at that and think that it's 5 and not think that it's 0.5. They may miss that decimal point somehow. And 0.5, which is half of 1, is a big difference from 5. Okay? So we don't want to make that error. That can harm someone as well. Okay? So remember, no trailing zeros for whole numbers. No, I'm sorry, and yes, always have leading zeros for any decimals. Okay? And a decimal number is anything that's less than 1. I have bolded things in red that are very important. Please try to remember those. Okay? Now, my last bullet on this slide is 0.5, which is half of 1, never be written as 1/2. So 1/2, 1/2. Okay? So it can never be written in as a fraction. For med math, you cannot write it as a fraction. If the question wants you to write the answer as a fraction, it will ask you to do that specifically. Typically, med math uses decimals, and if there's an exception, your question will specify that requirement. Please do not leave points on the table by writing 1/2 in a fraction form and not 0.5, because I do not have the authority to accept that answer if you document it incorrectly. All right? Thank you. To avoid common mistakes, slide number 3. So for your test, you do not need to write the units. Okay? So again, for this particular quiz, you do not need to write the units. In the event that units are ever needed to be written, your question stem should state that. Okay? But I am telling you, do not write down units. Do not write down mLs. Do not write down milligrams. You're just writing the number. Okay? There's a lot of fill in the blanks, and you're just writing the number. So for example, write 10 if that's your answer. Okay? That's the correct way to document. Do not write 10 mLs. That is incorrect. Okay? So if you write 10 mLs, the computer will recognize that as incorrect. Plain and simple. End of story. All right, so here is our 24-hour clock. In the middle, very center, we have our white section. That is AM military time. On this clock, it has 0000 as well as 2400. I know there was debate in the classroom versus whether it's 2400 or 0000, and I have not seen this in our ExamSoft test bank, as I mentioned before. So I would say don't be concerned. Okay? You know 0000 is not 9 o'clock, and you know 2400 is not 9 o'clock. So, or any other time other than 12 a.m. So if you see either of these, it's 12 a.m., period. Now, the next layer is our traditional analog clock. All right, so we're going from 1 to 12. Okay, if your military time is PM, that's our outer layer. Okay, that's our outer layer, and then it is beginning with 1200 and it's going around to 2300. Okay, so I thought this clock was much better than looking at two separate clocks. So I hope this helps you, but you must know how to tell military time and to convert it into military time. If in fact you see on the test where they do not have an AM or PM, please just assume it's AM, because I believe I did see a question that was a typo. All right, here are your units of measure that you absolutely must know for our exam and for the semester one. Of course, there's other units of measure that you will need to know as well. We talked about teaspoons, 5 mLs in 1 teaspoon, 15 mLs in 1 tablespoon. It's good to commit that to memory today, but these are the things I absolutely want you to know on Monday. I wrote down here how to convert kilograms to pounds and how to convert pounds to kilograms. So I will go over that right now. But the rest of this stuff you must just memorize. Absolutely just memorize. Okay? 1 kilogram is equal to 2.2 pounds. Kilogram to pounds, if you're converting from kilogram to pounds, it's just different metric systems, okay? But if you're if we're talking about what is larger, kilograms are definitely larger than pounds, which is why one of them equals 2.2 of the pounds. Okay, kilograms to pounds, you're just multiplying by 2.2, and then you have your answer. If you're converting from pounds to kilograms, then you're dividing by 2.2, and then you have your answer. Simple as that. Everything else, just memorize. This is the formula that we most commonly use in class. I am not going to go over ratio and proportion and dimensional analysis. This formula is the only one I'm going to go over. In fact, you want to utilize the other formulas. You have them in your notes as well as on your handouts that was given. And they're also on Canvas and the PowerPoint in Nursing 215P. All right, so we have desire over have. So desire is what is ordered. What is the amount of medication that we must give the patient? Okay, that's what's desired. Okay, and then what we have is what was given to us from the pharmacy in the particular form in which it was given. So it could be tablets, it could be elixir or liquid, it could be an inhaler, it could be multiple things. Okay, and the supply is the units in which it is the amount that we have is equivalent to. Okay, so for instance, it could be 1 ml is equal to 1 milligram. So the 1 milligram is what we have, and the 1 ml is the supply, because the supply is the dose, how we're going to calculate the dose to give. Okay, or it could be 5 mLs is equal to 1 milligram. So that's when it gets tricky and the supply changes from 1 milligram to 5. 1 milligram as of have is what we have to supply of 5 milliliters. All right, so what do? You take what you have, you divide it by what you desire, and then you multiply it by what is supplied, and that will give you the dose to give your patient. Let's try this example. So we have morphine 2 milligrams, and then that is what is ordered. Okay, what we have on hand from the pharmacy in our bottle is 1 milligram is equal to 1 ml. Okay, and this is a 30 ml bottle. Now, again, your questions on your exam will have scenarios. You have to be able to read it, realize what they're asking you, what do they want to know, pull out the information that you need, and solve the formula. I have put the information out for you. I have not given you a scenario, but you should be able to read that scenario and know exactly what they're asking you for and gather the correct information. Okay? Back to our sample. So we have 2 milligrams of morphine that is ordered. We have on hand 1 milligram is equal to 1 ml, okay, or 1 milligram per ml. That's what 1 mg/ml means. And we have a bottle with 30 mLs in that bottle, okay? So 30 mLs in the bottle means that there's 30 milligrams in the bottle because 1 milligram equals 1 ml of morphine. All right? This is a problem, I believe we did this in class, but I'm just making sure that we're clear. So, what is desired? 2 milligrams is desired. So, before we even start talking about desired over half and supply, let's talk about what does this problem want from me? They want you to tell them exactly how much medication in mLs, because that's our measuring unit, according to the bottle that was supplied by the pharmacy or what we have on hand from the pharmacy. How many mLs are you going to give your patient? Okay. So again, our order is for 2 milligrams. Some can solve this in their head, but we're going to go through the formula. So 2 milligrams is desired, so that number goes on the top. What do we have on hand as far as milligrams are concerned? And we have 1 milligram per ml. Okay, so 1 milligram on the bottom, because that's what we have on hand or what we have available to us. 2 milligrams on top, which is what is ordered and what we desire to give our patient. And now we need to find out how many milliliters is 2 milligrams equal to. So you divide the 1 milligram into the 2 milligrams and you get 2. Then you want to multiply that 2 by 1 ml. And the reason we're using 1 ml is because our example says 1 milligram per ml. Okay, so ml is how our medication is supplied to us. Okay, supplied in as a liquid, and the measuring units is ml. So 2 milligrams times 1 ml is going to give us 2, which gives us the dose that we're going to give our patients, and that means we're giving them 2 mLs. Okay, good enough. So converting from larger units to smaller units, you're going to use multiplication if you're not going to utilize the decimals, the moving of the decimals. All right, so with multiplication, disregard anything I say about moving the decimals and just find out what's equivalent to the unit of measure. So for instance, you have 1 gram equals 1,000 milligrams. So if you're converting from larger to smaller units, then you are just multiplying the converting unit, which is the gram, by 1,000. And that would then give you your answer. So if you were converting 1 gram to milligrams, you would just multiply 1, which is the converting unit, gram, by 1,000, and it will give you 1,000 milligrams. So if you were converting 2 grams to milligrams, then you would multiply the number 2 by 1,000, because 1,000 milligrams is in 1 gram. That's the converting units equivalent, and that will give you 2. All right, now if you are a person that uses the decimal, moving of the decimal places, so you just want to know that when you're going from larger to smaller, you want to, if smaller is the end goal, you move into the right, okay? So when I say the end goal, I'm talking about the size of the unit. So we have kilograms. 1 kilogram is 1,000 grams. 1 gram is 1,000 milligrams. And 1 milligram is 1,000 micrograms if you look at our analog over here that I have for you. Okay, so bullet number 2 It says, note that the unit is converting from grams, the larger unit, to milligrams, a smaller unit, thus changing the factor of 1,000 because there is 1 gram is equal to 1,000 unit grams. So our changing factor is 1,000, which has 3 zeros in it. Okay, so 1,000 milligrams equal 1 gram. We got 3 zeros. We are moving 3 spaces because we have 3 zeros. And we are moving the decimal point on the converting unit. Okay, the unit that is converting is grams because we're moving the larger unit to the smaller unit. Okay, so for our 1 gram, we have our imaginary decimal point behind the 1. All whole numbers have a decimal point behind it, right? You're going to move it to the right 3 times. So you move it once, you're adding a 0. You're moving it twice, you're adding a 0. You're moving it 3 times, and you're putting your decimal point down. So you have 1, 0, 0, 0, which is 1,000. So 1 gram is equal to 1,000 milligrams. Okay, now let's look at bullet point number 3. The decimal points will decimal point will be moved 3 places to the right to complete this conversion. So I have 0.008 grams. And 0.008 grams is converting to 8 milligrams. All right, here we go. So we have our decimal point. We're going to move it 3 spaces because our factor of change is 1,000 for the unit of measure of a milligram to a gram, because 1,000 milligrams equals 1 gram, right? Okay, so 1,000 is the number of our factor change, which means we're moving it 3 zeros because it's 3 zeros in 1,000. So you move it to the first 0, second 0, and then you move it behind the 8, and our answer is 8 milligrams. So 8 milligrams is equal to 0.008 grams. All right, hope that helped. So on this slide, I wrote out the conversion from the smaller unit to the larger unit. So micrograms is the smallest unit, kilograms are the larger units or the largest unit. So micrograms, 1,000 micrograms equals 1 milligram, 1,000 milligrams equals 1 gram, 1,000 grams equals 1 kilogram. If you are trying to convert using division, you do not need to listen to anything concerning the moving of the decimals. You are just going to divide your smaller unit by whatever that conversion is. So, for instance, if you look at 1,000 milligrams is equal to 1 gram, that means you would take 1,000 milligrams, and then which is the smaller unit, and then divide it by 1,000, and that would give you 1, meaning 1,000 milligrams is equal to 1 gram. Okay? Now we're going to go over with the decimal points. So with the decimal points, moving the decimal points, you're just noting that you're moving to the left. If you're moving to something larger, you're moving to the left. Okay? And what are you moving to the left? You're moving your decimal point. So 1,000 milligrams behind that last 0 is a decimal point. You don't see it, but we all know whole number has a decimal point at the end. You're going to move it 3 spaces to the left, and you're moving it 3 spaces because there's 3 zeros in 1,000, and 1,000 is the equivalent units, right? 1,000 milligrams is equal to 1 gram. So you're going to use 1,000, you're going to move it 3 spaces to the left. That will have your decimal point right behind the 1, which basically is your answer. 1,000 milligrams equals 1 gram. Easy peasy. Now, if you look at bullet point 3, you can do that with bullet point 3 as well. So 8 milligrams is equal to 0.008 grams. And how did we get that? So there is an imaginary decimal point behind the 8. Milligrams is the smaller unit. If we look at our scale up the top here on the left-hand side, so there's 1,000 milligrams in 1 gram. So we're going to move it 3 times. The decimal points will move 3 times because there's 3 zeros in 1,000. So 1 in front of the 8, then you add a 0, 2, and then you add another 0, 3. You put your decimal point down. You always put your leading 0, and the answer is 0.008 grams. Is equal to 8 milligrams. I want you to know that I do believe you. Make me proud on Monday. I want everyone to do well. We're thinking positive thoughts. We're putting our RAS out there, and it's coming back with 90s and hundreds only. No one taking the test more than once. Wish you guys the best.